Hello, welcome to Ababil Math World. Today we are going to solve an interesting problem. K square is equal to 8i, where I is the square root of minus 1. So for this, we solve the problem in this way. The solution, so the given equation is K square is equal to 8i. Here the left hand side is an imaginary number, that is a complex number. So here what we assume is let k is equal to a plus ib, where a and b both are real numbers. So now substituting this k is equal to a plus ib in the above equation, so we get a plus ib whole square is equal to 8i. Expanding this using the formula a plus b whole square, that is equal to a square plus 2ab 2a times ib plus b square, that means ib whole square is equal to 8i. So here a square plus 2ab times I, and here I square is minus 1 and minus b square it becomes is equal to 8i. So here the real terms are a square and minus b square. So writing a square minus b square as the first two terms and collecting them with a bracket, and here next we write 2ab times I is equal to this 8i. Instead of writing 8i, I can write 0 plus 8i. Now comparing the real and imaginary parts on both sides. So here the real part is a square minus b square. So a square minus b square is equal to 0. And comparing the imaginary part, that means the coefficient of I. Here the coefficient of I is 2ab. And on the right hand side the coefficient of I is 8. So 2ab is equal to 8. So from this one, a square minus b square is equal to 0. We get a square is equal to b square. And from this equation, 2ab is equal to 8. If I write b is equal to, if I make b as the subject of this equation, b is equal to 8 by 2a. Now cancelling by 2, it becomes 4. So b is equal to 4 by a. That means we have a square is equal to b square and b is equal to 4 by a. So substituting this value of b, that is b is equal to 4 by a, in equation a square is equal to b square. So here we get a square is equal to b is equal to 4 by a. So writing 4 by a whole square. So a square is equal to 4 square is 16 by a square. And next, upon cross multiplication, a square into a square becomes a square whole square by 1. Here 1 into 16 is 16. So now this can be written as a square whole square is equal to, this is 4 square, we can write 16, and writing all terms at one side, a square whole square minus 4 square is equal to 0 we have. So this is a square whole square minus 4 square is equal to 0 comes under the form a square, or say x square minus y square type, and this becomes x plus y times x minus y. So using this algebraic identity, so here we can take x as a square and y as 4 square. So then the equation can be simplified in this way. So here we have a square, that is x plus a square plus 4 times a square minus 4 is equal to 0. The product of two numbers is 0. Either one of them should be 0. So a square plus 4 is equal to 0, or a square minus 4 is equal to 0. If a square plus 4 is equal to 0, we get a square is equal to minus 4, and a is equal to plus or minus root minus 4, and a is equal to plus or minus root 4 is 2 and root minus 1 is I. So we get plus or minus 2i. And in the same way, if a square minus 4 is equal to 0, a square is equal to plus 4, and a is equal to plus or minus root 4, and we get a is equal to plus or minus 2. So at this stage, we got 4 values for a, plus 2i minus 2i, and here 2 values for a we got, a is equal to 2 and a is equal to minus 2. So for each value we see what are the possible values of b we get. So now we can here recall that b is 4 by a. So now substituting first a is equal to 2i in this equation, b is equal to 4 by a. So we get, say the case 1 we can take it. So if a is 2i, then b is equal to 4 by a. A is 2i. So cancelling by 2, we get 2. So b is equal to 2 by I. And we further know that, so if we this rule we know it, I is minus 1, root minus 1. So I times minus I is equal to, say it, I times minus I. I times I is minus 1, and minus of minus 1 is plus 1. So this gives, if we want minus I, then it becomes 1 by I. Or from this we can say that I is the reciprocal of minus I, and minus I is the reciprocal of I. So using this one, so here it is actually 1 by I. 2 by I is 2 times 1 by I, and 1 by I is minus I. So b is equal to minus 2i it becomes. So one value is, when a is 2i, b is minus 2i. In this case, k becomes a plus ib. So k is equal to a is 2i plus b is minus 2i. So minus 2i times I. So this becomes 2i plus minus is there, minus 2, and I into I is minus 1. Minus 1 into minus 2 is plus 2. And generally in writing the standard form of a complex number, we write real part first. So that's why I'm writing 2 plus 2i. This is one value of k. Let me call it k1. This is the first value we obtained here. So now case 2, in case 2, I take a is equal to minus 2i, and then what I get here is, so as we know, b is 4 by a. So substituting a is equal to minus 2i, b is equal to 4 by minus 2i. So now b is equal to, cancelling by 2, we get 2 by minus I. As we have seen just now, minus I is 1 by I, and minus 1 by I is I. So therefore b is equal to, this is 2i. And the value of k which I get here, let me call it k2. K2 is a plus ib. So this is equal to, a is minus 2i plus I times the value of b we obtained here is 2i. So now minus 2i, I into I is minus 1. So minus 1 into 2 is minus 2. So if we write the real number first, minus 2, and next we write the imaginary part, minus 2i. So this is the value of k we got here. That is minus 2 minus 2i. Two more values of k are possible here. For two more values of a, so that those two values, right, k3 and k4. To get k3, so first of all here let me write it case 3. So in this case 3, what I have to take is the value of a first I have to take. So a is equal to plus 2 and minus 2 we take. When we take a is equal to 2, then b is actually 4 by a. So then b is equal to 4 by 2. Then b is equal to cancelling by 2. We get 2. So when b is 2, for a is equal to 2, we got b is equal to 2. So the value of k, which is k3 I call, k3 is equal to a plus ib, and a is 2. 2 plus 2i is the third value of k which I got here. But this 2 plus 2i is same as this value of k, that is k1 I called 2 plus 2i. So here what I arrived is this k3 is not a different one, but it is equal to k1. The third solution coincides with the first solution, so it is not a different solution. We can go for the fourth case, in which a is equal to minus 2 I take, and b is 4 by a. So b is equal to 4 by minus 2. So b is equal to, cancelling by 2, we get minus 2. So when b is minus 2, then the fourth value of k we get is a plus ib. So a is minus 2 plus, here I write I times b is minus 2. So that is minus 2 minus 2i. This value of k, that is k4 is equal to minus 2 minus 2i, is also not a different value. So here already we obtained this value. K2 is equal to minus 2 minus 2i. So this k4 is equal to k2. So actually we have only two different values of k obtained. So one value of k we obtained is 2 plus 2i, and another value of k we got here is k is equal to minus 2 minus 2i. So these are the only two different solutions we obtained. So if you like this video, please subscribe to my channel. Thank you for watching.